If you could travel alongside a photon, the entire universe might drift through billions of years, but for that particle of light, time would seem as though it had not even begun. Welcome to Drift into Quiet Knowing. Tonight, we will step into a question that is very strange, very deep, and also very quiet. If you could travel alongside a photon, how would time disappear? Imagine a tiny particle of light just born in the blazing heart of a distant star. It leaves that place behind, rushing through the darkness between the stars, crossing stretches of space so vast that the human mind can barely hold them. For us, that journey here might last thousands, millions, or even billions of years, but for light, the story becomes far stranger. According to modern physics, we cannot truly sit on a photon, and we cannot ask it what it sees, because a photon does not have a resting state the way a human being does. But that very impossibility opens a beautiful door for us to understand time more deeply. The closer something moves to the speed of light, the more time slows down compared with an outside observer. And when we think about that final limit, where light is always moving through the vacuum of space, our familiar idea of time begins to soften, to blur, like a dream dissolving into the dark. By the end of this journey, you will understand why light can travel across the vast universe without aging the way we do. You will see that time is not a river flowing the same way for everything, but a hidden part of space, motion, the body, memory, and life itself. And perhaps, when you understand why a photon does not carry old age with it, you will also look at the smallest moments of your own life with a little more tenderness. Now, let your breathing soften. Let the room become a little quieter. In front of you, imagine a tiny particle of light moving through the darkness. Do not try to catch it, just travel with it in your mind. Because the closer we come to light, the more we realize that the deepest mystery is not how fast a photon flies, but what time truly is when no one remains to grow old with it. Let us begin with a very small scene. A quiet room at the end of the day. Outside, the sky has grown dark. Inside the room, there is only a thin streak of light slipping through a gap in the curtains, or a very gentle nightlight resting quietly on the wall. You may have seen a scene like this thousands of times in your life, but rarely stop to ask yourself, what is it, really, that is touching your eyes? It is not only light in the familiar sense, it is a stream of tiny signals, quiet little packets of energy, photons arriving from somewhere, travelling through space, and ending their journey right on your retina. Something as ordinary as light in a room is opening a doorway straight into a deeper question. If you could travel alongside a photon, would time still mean anything at all? A photon is a quantum of light. To put it more gently, it is the smallest portion of light when light is emitted or absorbed. When an atom receives energy, an electron inside it can jump to a higher energy level. When that electron falls back down to a lower level, the extra energy can be released into the universe as a photon. This can happen in the burning heart of a star, in the filament of a light bulb, in a glowing screen, in a small candle flame, or in thin clouds of gas between the stars. Each photon is like a tiny letter from nature, carrying information about the place where it was born. But we have to be careful. A photon is not a tiny marble flying through space the way we might imagine in everyday life. It is a quantum entity with qualities that are particle-like and wave-like at the same time. It refuses to fit neatly into the familiar pictures the human brain often uses to understand the world. The first strange thing is that a photon has no resting mass. A stone has mass. A drop of water has mass. Your body has mass. Because we have mass, we can stand still, sit down, sleep through a long night, then wake up and feel that time has passed across our skin, through our breathing and inside our memory. But a photon is different. In a vacuum, it always moves at the speed of light. It does not have a resting state like a chair in a room or a person lying in bed. So from the very moment it appears, a photon belongs to a very different kind of existence. It does not step into time the way we step into a new day. It does not move little by little through morning, afternoon, and nightfall. It appears as a unit of energy in the electromagnetic field, and in a vacuum, it moves at the fastest limit nature allows. Imagine a photon born in the core of the sun. In that place, the temperature and pressure are so intense that matter no longer resembles the peaceful things we see on Earth. Energy is created through nuclear reactions, and after countless complex interactions inside the Sun, light can finally escape from that brilliant surface. When a photon leaves the Sun and travels through space to Earth, it takes a little more than 8 minutes to arrive from our point of view. Those 8+ minutes are enough time for you to make a cup of tea, sit by a window, listen to a slow song, or close your eyes for a few breaths. But a photon has no heartbeat with which to feel whether those 8 minutes are long or short. It has no brain to remember the journey. It carries no feeling of exhaustion. It is simply light in motion, and that difference is the starting point for a larger mystery. Time is very real for a living body, but when we speak about light, the way we talk about time has to become much more careful. Another photon may come from much farther away, not from the Sun, but from a star that was already shining before humans built cities, before the first languages were written down, before many of humanity's memories even began. That light crosses the darkness between stars, passing through regions of space so cold and vast that no sound could ever echo there. Then, on some quiet night, it reaches your eye as a tiny point of light in the sky. To you, it is only a star, but in truth, your eye is receiving a small message from the past. That photon does not speak in words. It has no writing, no voice, and no sentence to deliver, yet it carries traces of the place where it was born. Its color, its energy, its frequency, all of these are ways the universe whispers. This is what happened very far away, very long before you lifted your head to look up. When we say a photon carries energy, that does not mean it carries some vague kind of energy. In physics, the energy of a photon is directly related to the frequency of the light. Light with a higher frequency means each photon carries more energy. Red light has lower energy photons than violet light. Ultraviolet light is more powerful than visible light in many cases. X-rays and gamma rays carry even more energy. So light does not differ only in the colors our eyes can see. It also differs in the level of energy hidden deep inside each photon. A photon of red light entering your eye helps create the gentle warmth of the color red. A photon of blue light may bring a feeling that is cooler, more distant, but behind those feelings is a quiet truth. Every color you see begins with very small photons, particles of light that do not age the way your body ages. There is something very beautiful in this. When light touches the eye, it is no longer only physics outside of us. It becomes an experience inside of us. Inside your retina are light-sensitive cells. When a photon is absorbed, it can trigger a delicate chain of biological reactions. From there, an electrical signal travels through the optic nerve, enters the brain, and the brain builds an image. A streak of light on the wall becomes sunrise. A point of light in the sky becomes a star. The golden glow of a candle becomes a feeling of warmth. A face lit by soft light becomes a memory. In this way, a photon has no memory of its own, but when it touches a conscious living being, it can awaken memory. It does not know how far it has traveled, but when it reaches you, it can bring forth a room, a loved one, a sky, an evening you may remember for the rest of your life. This is where the difference between light and human beings becomes very clear. A photon does not age because it is not a body repairing its cells one by one. It has no skin for time to touch. It has no breath that slows when it grows tired. It has no inner life that feels the past drifting farther away. But human beings do. We see light with our eyes, understand light with our brains, and feel light with the whole life that is gathered inside us. A ray of late afternoon sunlight may remind one person of childhood, remind another of someone who is gone, and make someone else feel peaceful without knowing why. A photon does not carry that emotion inside it. Emotion is born when light meets a mind living in time. So if a photon is a messenger of space, a human being is the place where that message becomes meaning. Think of a candle in a dark room. As the wick burns, the atoms and molecules in the flame become excited, then release light. Photons leave the flame in every direction. Some into the wall, some are absorbed by objects, some fly straight into your eyes. To you, the candle burns for 10 minutes, 20 minutes, and then slowly grows shorter. The wax melts. The darkness around the room changes. Time becomes very visible in the wearing down of the candle. But each photon leaving the flame does not have a life that lasts the way the candle's life lasts. It does not sit there watching the wax melt. It does not feel sad because the flame is about to go out. It is simply emitted, travels through space and is absorbed somewhere else. For us, that is a process unfolding in time. For a photon, we cannot assign that kind of inner story to it. And it is exactly that silence that makes light feel both scientifically precise and mysteriously beautiful. In the same way, imagine a photon from a distant star. Perhaps that star no longer exists. Perhaps it expanded, collapsed, or changed a very long time ago, but its old light is still travelling through space. When that photon reaches a telescope, it is not just present light. It is a piece of the past delivered late. This makes the night sky a living museum of time. When we look up, we are not seeing the universe exactly as it is in one single moment. We are seeing many layers of the past stacked together. Light from the moon arrives very quickly. Light from the sun takes a little more than 8 minutes. Light from distant stars takes many years. Light from faraway galaxies may take millions or billions of years. Yet all of that light appears in our eyes as one quiet sky. We are standing in our own present, but light carries the past into that present in a very gentle way. And this is where the question about photons begins to lead us toward the question of time. If a photon has crossed space for millions of years according to our clocks, then has it experienced millions of years? The answer has to be very careful. We should not imagine a photon as a tiny traveller with a seat, a window, a journal, and a feeling of waiting. A photon does not have a rest frame the way an object with mass does. We cannot truly place ourselves in a position of being still alongside a photon. But what we can say is this: light does not have its own time in the familiar sense that a living body does. It does not age along the way. It is not worn down by years the way stone, trees, flesh, or memory can be. What we call the time of a photon cannot be told in the same language we use to tell the story of a human life. One gentle way to understand this is to compare a photon to a letter and the person who reads it. A letter may be sent from very far away. It crosses oceans, cities, and many hands before finally arriving in front of you. For the sender and the receiver, there is a period of waiting, there is longing, there is change. The sender may be older by the time the receiver reads the letter, but the message inside the letter is not sitting there feeling the days and months go by. It is simply carried, then opened somewhere else. A photon is similar in a very limited sense. It carries physical information from the place where it was emitted to the place where it is absorbed. But it does not have a tiny soul counting each moment along the way. When we say light comes from the past, that is how observers like us understand its journey through space-time. It is not because the photon has been sitting there remembering its own past. This does not make light any less wondrous. In fact, it makes light more wondrous. Because light has no memory, yet it can awaken memory. It does not age the way humans do, yet it lets us see things in the universe that have aged. It does not need a material path to travel through, yet it can cross the enormous vacuum between the stars. Sound needs a medium such as air or water in order to spread, but light can travel through a vacuum. So when a distant galaxy sends its light to us, it does not need an invisible thread stretched across the universe. The electromagnetic field propagates through space on its own, and photons are the way we describe the tiny packets of energy in that field. In the absolute silence between the stars, light still travels, and during that journey, it does not need to breathe, does not need to rest, and does not need a night to recover. Maybe you have once lain in a dark room and watched a streak of light from the window fall across the ceiling. That streak of light looks very soft, very still, almost motionless. But in truth, photons are constantly arriving and leaving. The light you see is not an object standing still on the wall. It is a countless number of interactions taking place. Photons are emitted from a light source, travel through the air, reflect off surfaces, and some of them enter your eyes. The brain gathers those signals into a stable image. So what you experience is a peaceful scene, but underneath it is an extremely fast flow of energy and information. This is a little like our own lives. On the outside, things may seem very still, but inside there is the heartbeat, the bloodstream, nerve impulses, thoughts, memories, and time quietly passing through. When we think about photons, we also touch a humbling truth. Most of the light in the universe is not visible to the human eye. Our eyes are sensitive only to a very narrow band called visible light. Beyond the red, we can see there is infrared. Beyond violet, there is ultraviolet. Farther still are radio waves, microwaves, X-rays, and gamma rays. All of them belong to the family of electromagnetic radiation. They differ only in wavelength, frequency, and energy. so the universe does not shine only in the colours our eyes know. It speaks in more voices than we can hear. A radio telescope can see signals the naked eye completely misses. An infrared telescope can look through cosmic dust and reveal hidden regions where stars are being born. An X-ray telescope can reveal hot gas around black holes or the remains of stellar explosions. Each kind of photon opens another layer of reality. And each layer reminds us that what we call seeing is only a small part of what truly exists. But whether it is the gentle red light in a room or a high-energy gamma ray from a violent cosmic event, a photon is still unlike us in this fundamental way. It does not live inside the inner stretch of time. It has no youth, no old age, no first morning, and no final night. Human beings, however, do not merely exist in space. We live through the feeling of time. A long day can make us tired. An old year can leave traces on the face. A memory can grow distant and still remain bright inside the heart. We do not measure time only with clocks. We measure it through our own changes. So when we ask why light does not age the way we do, we are also asking a deeper question. What makes aging happen? Is it only the number of years that pass? Or is it the ability of living matter to carry memory, injury, repair, and emotion through every moment? A photon leaving a star does not carry a wristwatch. That sentence sounds simple, but it contains an entire depth. A clock only has meaning when there is a physical system that can pass through successive states according to its own proper time. Your body is an enormous biological clock. The heart beats, the lungs breathe, the brain changes, cells divide, skin heals and then is wounded again. Memories form and fade, and you can look back and say, I was there, I loved, I worried, I stayed awake all night, I felt peace. A photon cannot say that. Not because it is silent in a poetic sense, but because it is not a living subject with experience. It is a quantum particle of light, and as it travels through the universe, whether the journey is long or short is mostly a story told by an observer who has a clock, a position, and a time of their own. Perhaps that is why light feels both familiar and foreign. It touches our faces every morning, yet its nature reaches beyond ordinary feeling. It makes the room appear, yet it does not need the room in order to exist. It shows us time, yet it does not age the way the things it illuminates age. A ray of light falling on a table can show you dust drifting slowly through the air. It can reveal that the book has grown older, the wooden surface has faded, and your hand has changed over the years. Light reveals the traces of time on everything, but the photon itself does not wrinkle, does not lose its colour, and does not grow tired from the distance it has crossed. It is an ageless messenger, while we are the receivers of the message, living inside bodies that have an age. And if tonight we hold that thought quietly in the mind, something gentle begins to appear. Light does not age the way we do, but for that very reason, it also cannot have the things we have. It does not know what it feels like to sit beside a window while rain falls outside. It does not know the warmth of a room after a long day. It does not know the feeling of closing its eyes and letting an old memory drift slowly by. It does not know that it has travelled far, it does not know that it has arrived. But we do. Even though time touches us, we are able to feel that touch. We can see a ray of light and wonder where it came from. We can hear a story about a photon and feel the universe become wider, while our hearts become quieter. We can grow older, but that very aging gives each moment its depth. So when we look at a photon as a tiny particle of light that carries the whole universe with it, we are not only talking about physics, we are talking about the strange relationship between light, time, and consciousness. A photon does not need age in order to belong to the story of the universe, but human beings need time in order to understand that story. A photon does not need memory in order to travel from a distant star to our eyes, but we need memory in order to turn that light into meaning. A photon does not need rest after a long journey, but we need sleep, we need quiet, and we need nights when the mind can soften. And in that difference, the first question becomes deeper. If we could travel alongside a photon, perhaps what disappears is not only the familiar clock, but the entire way human beings use the body, memory, and emotion to name time. Let that image stay with you for a little longer. A photon is born in a faraway place. It has no heart, no age, no longing, no dream. It moves through wordless darkness, carrying a small amount of energy, a frequency, a trace of the light source that created it. Then it touches the eye of a human being looking upward. In that very moment, ageless light meets an aging mind. Physics meets memory. Space meets meaning. And from one tiny photon, we begin to understand that time is not only something out there flowing past us. Time is also the way life feels itself when it is touched by light. If a photon is an ageless messenger, then the speed of light is the final road it always travels. We often say that light is fast, but the word fast is still not enough. A car can be faster than a person walking. An airplane can be faster than a car. A spacecraft can be faster than any familiar vehicle on the ground. But light in a vacuum is not only faster than all of those things. It is a fundamental limit of the universe. In a vacuum, light travels about 182 miles in 1 second, which is 299,458 meters in 1 second, nearly 186,000 miles per second, or about 300,000 kilometers per second. 1 second, to us, is only a heartbeat, a blink, a very short breath. But in that moment, light can already travel around Earth many times. And when we begin to understand that, the question, what if you could travel alongside a photon, is no longer a simple little thought experiment. It becomes a doorway into a place where time, mass, and motionness no longer behave the way they do in everyday life. Imagine a quiet morning. You're standing by a window and sunlight falls across your hand. The feeling is almost immediate, as if the sun is touching you in that very moment. But in truth, that light left the sun a little more than 8 minutes earlier. During those 8+ minutes, Earth kept turning, the wind kept moving through the leaves, someone had just woken up, someone had just closed their eyes, and someone else was passing through a very private thought. If we imagine the sun suddenly disappearing, we would not know it right away. The old sunlight would still keep reaching us for a little more than 8 minutes, because information about that change could not travel faster than light either. This shows that the speed of light is not only the speed of the thing that lets our eyes see, it is also the limit of information, of influence, of the way an event in one distant place can touch another place in the universe. From here, the night sky becomes much deeper. When you look at a star, you're not seeing it exactly as it is in one absolute shared moment. You're seeing light it sent out earlier. A star 10 light-years away from us means its light needs about 10 years to reach our eyes. A galaxy millions of light-years away means its light has travelled for millions of years, according to our clocks, before touching a telescope. So looking far into space is also looking deep into the past. The sky is not only a dome full of bright points, it is a book written in photons, where each ray of light is a small message from a different moment. Some light is as young as a few minutes. Some light is older than every city, every language, and every human memory. But when it reaches our eyes, all of it rests together in one quiet sky. This makes the phrase light year very beautiful, but also easy to misunderstand. A light year is not a unit of time, it is a unit of distance. It tells us how far light travels in 1 year. When we say a star is 4 light years away, it means light from that star needs about 4 years to reach the place where we stand. But the important point is that those 4 years are how we measure the journey with our own clocks. We should not imagine the photon as a tiny passenger sitting in a train car for 4 years, looking out the window, waiting and remembering. A photon has no heart with which to feel that the journey is long, no brain with which to count the months and days, and no body with which to grow tired. It carries energy and information through space, but it does not live in time the way a creature with memory does. Now try to imagine chasing a photon. At first, the image sounds fascinating. A ship leaves Earth, flies past the moon's orbit, goes beyond Mars, moves far away from the familiar planets, and keeps accelerating through the darkness. If the ship reaches 1/10 of the speed of light, it is already faster than anything in everyday human life. If it reaches half the speed of light, it has entered a region where human intuition begins to weaken. If it reaches 9/10 of the speed of light, time and space begin to reveal very strange effects. But no matter how powerful the ship is, if it has mass, it still cannot reach the exact speed of light. It can come close and then closer still, but it cannot become a photon. This limit does not exist because the engine is weak. It exists because of the structure of physics itself. In everyday life, we often think that if we want to go faster, we simply need more energy. A car needs more fuel, a runner needs more strength, a rocket needs more thrust. But for an object with mass, as its speed approaches the speed of light, everything becomes extreme. The faster it goes, the more energy it needs in order to gain even more speed. As it moves closer and closer to the speed of light, the required energy grows enormously. And for an object with mass to reach the exact speed of light, the required energy would become infinite. To put it more gently, matter with mass can dream of light, and it can travel near the road of light, but it cannot fully step into the state of light. The human body, a spacecraft, a stone, a drop of water, all of them belong to the world of mass, and that world cannot cross this final boundary. It is at this boundary that time begins to change. According to special relativity, when an object moves very fast compared with an observer, time for that object passes more slowly compared with that observer. This does not mean the person sitting inside the ship feels that everything in the ship has slowed down like a dream. For that person, the clock still runs normally, breathing still feels steady, and thoughts still follow one another. But when we compare that person with someone who stayed behind, the difference appears. If the ship travels extremely fast and then returns, the person on the ship may have aged less than the person on Earth. At ordinary speeds, this effect is so small that we do not feel it. But as something approaches the speed of light, the effect becomes large enough to shake our familiar feeling that 1 second is the same everywhere. Imagine two identical clocks. One rests on a table in a quiet room, the other is placed on a ship flying close to the speed of light. Before departure, both clocks show the same time. The person who stays behind looks at the clock on the table, and each second passes steadily. The person on the ship looks at the clock inside the ship, and each second also passes steadily. No one feels that their own time is wrong. But when the ship returns, the two clocks may no longer agree. The clock that travelled very fast may have recorded less time. That shows us that time is not an absolute flow that is the same for everyone and everything. Time depends on motion, on the frame of reference, and on the way an object travels through space-time. But even though time on the ship slows down, the ship is still not a photon. The person on the ship still has their own proper time. They still have a body, mass, a heartbeat, memory, and the feeling of waiting. They can hear the engine and look at a clock, think about people at home, and feel sadness, joy, tiredness, or peace. Because they have not reached the speed of light, they still live inside the story of time. A photon is different. We cannot place a tiny clock on a photon and ask how long it has been travelling. We cannot sit beside a photon in its own resting frame, because a photon has no resting state the way an object with mass does. So travelling with a photon is a beautiful image for reflection, but it is not a journey that physics allows us to take in the ordinary sense. The speed of light is also the limit of how the universe communicates with itself. A radio signal sent to a distant probe is electromagnetic radiation, a close relative of light. In a vacuum, it also travels at the speed of light. When the probe is still near Earth, the signal arrives relatively quickly. When the probe is very far away, a command may take many minutes or even many hours to get there. No one can control a spacecraft in the far reaches of the solar system as if they were playing an instant game in the same room. The universe forces us to wait. Distance becomes signal travel time. This sounds simple, but it is very deep. No place can know every other place instantly. Every piece of news needs a path. And the fastest path nature allows is still the path of light. When we understand that, we begin to see the present with a different feeling. In everyday life, we often imagine now as a curtain spread over the entire universe all at once. But on a very large scale, that idea is no longer simple. An event happening in a distant galaxy will not enter our present until light or some signal from it reaches us. A star may have exploded a very long time ago, but we may still not know it, because the light from that explosion is still on its way. Some faraway place may have changed completely, but in our eyes, it still appears as the past. So light connects us to the universe, but it also reminds us that we always see the universe through a delay. We do not see reality instantly. We see messages that have crossed distance in order to reach us. Perhaps this is one of the things that makes the speed of light feel mysterious without needing any extra magic. Science itself is already strange enough. A speed limit keeps cause and effect from falling into chaos. A speed limit prevents information from spreading across the universe instantly. A speed limit keeps objects with mass from catching up to photons. A speed limit makes time pass differently for fast-moving objects than for observers who stay still. And that same limit makes the night sky a place filled with the past. Light from distant stars is beautiful not only because it sparkles. It is beautiful because it is the trace of an event that left long ago, a fragile message from the universe arriving late in the night. Think of thunder and lightning. When a storm is far away, you see the lightning first, and a few seconds later you hear the thunder. Light arrives much faster than sound. The pause between lightning and thunder helps us feel the distance. In the night sky, something similar happens on a scale larger than we can imagine. Light from stars and galaxies also needs time to arrive. The only difference is that the waiting time is no longer a few seconds. It may be a few years, a few thousand years, or a few million years. Each photon is an echo made of light, not sounding in the ear, but appearing in the eye. It tells us that a distant place once shone. It tells us that the past can still touch the present, but it also tells us that the photon is not sitting inside that waiting time the way a human being waits for a sound. The waiting belongs to us. It belongs to our clocks. It belongs to the way we measure the universe. If we kept accelerating forever, could we slow our own time until it almost disappeared? In theory, when an object with mass moves very close to the speed of light, its time compared with the outside world can slow down a great deal. But the word close is very important here. Close is not the same as equal. A ship might reach a very large fraction of the speed of light in a thought experiment, but it still cannot reach the exact speed of light if it still has mass. The people on the ship would still experience their own proper time. They would still age, although they might age less than the people who stayed behind. A photon, however, is not simply a faster version of the ship. It belongs to a different kind of existence. It has no resting mass. It always travels at the speed of light in a vacuum, and it has no resting frame from which we can talk about its experience of time as if it were human. This helps us understand the main takeaway of the whole journey. Light does not age the way we do, not because it has some magical escape from age. It does not age in the human sense because it is not a living body, has no cells, has no memory, and has no internal clock like ours. And we also cannot truly travel with it to see the universe from the photon's point of view. But that very limit is what makes the question beautiful. It forces us to recognize that time is not a simple thing out there, flowing evenly for everything. Time is tied to motion, mass, and the observer. And for us, it is also tied to biological rhythms, tiredness, sleep, and memory. So the speed of light is not just a number in a physics book. It is the boundary between what is possible and what is impossible for matter with mass. It is the speed of sunlight traveling from the sun to your hand. It is the speed of a signal sent to a distant probe. It is the speed of starlight crossing the darkness to touch a human eye. It is the limit that gives the universe an order of cause and effect, allowing the past to reach us through light, but never allowing us to know everything instantly. And when we stand before that boundary, human beings become smaller, but not more meaningless. Because even though we cannot catch up with a photon, we can still understand part of its path. Even though we cannot escape time, we can still listen to time changing inside the story of light. There is a kind of tenderness in this limit. If we truly were light, perhaps we would not know how to wait. If we were photons, perhaps we would have no childhood, no evening to remember, no feeling of being tired and then finally resting. But we are not photons. We have mass, so we cannot reach the speed of light. We have bodies, so we pass through time. We have memory, so a ray of sunlight can soften something inside us. We have sleep, so after a long day, time can become slower, smoother, and lighter. And perhaps this is exactly what makes life precious. Light may not age the way we do, but it also does not know that it has crossed the darkness. We grow older, but we know that we have lived. So if you try to run after a photon, you will discover that light is not only faster than you, it belongs to a boundary that your body, your mass, and your biological time cannot cross. But instead of seeing that as a failure, we can see it as a very quiet invitation. We do not need to become a photon in order to learn from a photon. We only need to look at light and then understand that the universe has very deep limits. Within those limits, time is no longer an absolute river. It can slow down, it can depend on motion, it can make the person who travels fast age differently from the person who stays behind. And when we think about light, we touch a larger question. What is time really? When there are things that can cross the universe without carrying old age, the way human beings do. That thought stay in your mind for a little longer. A photon leaves the sun and reaches you after a little more than 8 minutes. A photon leaves a distant star and reaches you after many years. A photon leaves an ancient galaxy and reaches a telescope after millions or billions of years. To us, these are unimaginably long journeys, but a photon does not tell that journey as a life. It does not grow old in the darkness. It does not remember where it began. It does not feel joy when it reaches its destination. It is simply light travelling along the final limit of every journey. And when that light touches our eyes, the ageless meets the aging. A photon meets memory. The universe meets the mind. The speed of light meets the slow breath of a human being listening in the night. At ordinary speeds, time seems very simple. You look at a clock and see the second hand moving in steady beats. 1 minute passing in a quiet room feels the same as 1 minute passing outside in the yard, on a road, inside a slowly moving car, or under the soft glow of a nightlight at the end of the day. That feeling makes us believe that time is one shared river, flowing through everything at the same speed. The person who is awake, the person who is asleep, the leaf that is falling, the candle that is burning down, all of them seem to belong to one single current. But that is only the intuition of everyday life. It works for the slow speeds the human body is used to. When we begin to approach the speed of light, time is no longer that shared river. A minute is no longer simply a minute. It begins to depend on how you're moving through the universe. Einstein's special theory of relativity changed the way human beings understand time at the deepest level. Before that, it was easy to imagine that somewhere in the universe there was an invisible clock ticking evenly for everything. But modern physics shows that time is not separate from space and motion. Two people moving in different ways can measure time differently, not because one of them is wrong, but because the structure of space-time itself allows it. When an object moves very fast compared with an observer, time for that object passes more slowly compared with the observer's time. This effect is called time dilation. It may sound like a distant idea, but it is not imaginary. It is a real physical effect confirmed by experiments and by extremely precise measuring devices. Imagine two identical clocks. One stays on Earth, resting inside a quiet room. The other is placed on a ship that can travel close to the speed of light. Before the ship leaves, both clocks show the same time. The ship begins to accelerate, moves away from Earth, and travels through the wide darkness. The person on the ship still feels that everything inside the ship is normal. Their clock still ticks steadily. The heart still beats. The breath still continues. A story still has a beginning, a middle, and an ending. No one on the ship feels that their time has frozen or disappeared. But when the ship returns and the clock on board is placed beside the clock on Earth, the two clocks may no longer match. The clock that moved very fast may have recorded less time. That means the person on the ship has experienced less time than the person who stayed behind. The important point is that time does not disappear for the person moving quickly. The person on the ship still lives inside their own time. They still have before and after. They still have memory. They still feel themselves existing through each moment. But compared with the person who stayed behind, their time has passed more slowly. This is one of the deepest ideas in relativity. It says that time is not one single drumbeat echoing across the whole universe. It is part of the path an object takes through space-time. Two different paths can bring two different amounts of time. At everyday speeds, the difference is so tiny that we do not notice it. But when speed approaches the speed of light, that difference becomes large enough to shake our familiar feeling that everyone ages within the same flow. There is a very simple image that can help us feel this. Imagine a light clock. Inside it are two mirrors, one on top and one on the bottom. A beam of light bounces back and forth between the two mirrors. Each time the beam goes up and comes back down, the clock counts one tick. For someone resting with the clock, the beam of light simply travels straight up and straight down. But if that clock is inside a ship flying sideways at an enormous speed, an outside observer will see the path of the light become longer, like a diagonal line. Because light in a vacuum is always measured at the same speed, a longer path means one tick of that clock takes more time from the outside observer's point of view. From this simple image, we can understand why a fast-moving clock can run more slowly when seen from another frame. This does not happen because the clock is broken. It is not because the person on the ship is sleepy. It is not the psychological feeling of a day passing quickly or slowly. This is physical time. It is measured by real clocks. It appears in equations, in experiments, and in the way the universe works. If you are waiting for important news, 1 minute can feel as long as an hour. If you're living through a joyful moment, an hour can pass very quickly. That is psychological time. Time dilation in relativity is something else. It does not depend on emotion, it depends on motion. The faster an object moves compared with an observer, the more its time slows down in comparison with that observer. And the closer it gets to the simultaneous, the speed of light, the stronger that effect becomes. This is where our question begins to deepen. If a ship moving close to the speed of light can return younger than the world it left behind, then what happens to light itself? If a photon travels from a distant star to your eye after millions of years according to our clocks, does it grow old? Does it experience that journey like a traveller sitting in the darkness, waiting for the day it will finally be seen? The answer has to be handled very carefully. A photon is not an extremely fast ship. A photon has no resting mass. A photon has no resting state where we can sit beside it and ask how long it has been travelling. We cannot attach a tiny clock to a photon and tell the story as if it were a living being with experience. So when we talk about the time of a photon, we are reaching the edge of human intuition. Before we reach that edge, let us stay a little longer with things that have mass. Human beings have mass, spacecraft have mass, clocks have mass, a muon particle also has mass. Things like these can have proper time. That means if a clock travels with that object, the clock can measure the time that object experiences. When you are sitting quietly in a room, your proper time is the rhythm your body and the clock beside you are both moving through. If you fly on a very fast ship, your proper time still feels normal to you. But when it is compared with the time of someone who stayed behind, the two rhythms are no longer absolutely the same. This is what makes time both real and soft. It is real because it can be measured. It is soft because it is not the same for every motion. One famous example is the story of the twins. One twin stays on Earth, the other boards a ship that travels close to the speed of light, goes to a very distant place and then returns. When they meet again, the travelling twin may be younger than the twin who stayed behind. That story sounds like science fiction, but it is based on a real principle of relativity. The traveller does not feel that they have lost time. Inside the ship, they still live through each day of their own life. But their path through space-time is different from the path of the person who stayed behind. So the amount of time they experience is different too. Emotionally, this feels very strange. Two people who once had the same age and the same childhood memories may no longer be the same age, simply because one of them moved through the universe at an extremely high speed. Time, which once seemed perfectly fair, turns out to depend on the journey. In reality, humans do not yet have a ship that can travel close to the speed of light like that street. But we do not need to wait for such a ship to see that relativity is real. Extremely precise atomic clocks have shown that time can change when clocks are moving or when they're in different conditions. In famous experiments, atomic clocks were placed on airplanes that flew around Earth and were then compared with clocks on the ground. The difference was very small, only tiny fractions of a second, but it matched the predictions of relativity. This makes the story feel less distant. Time does not change only in imaginary journeys between the stars. It changes even in the real world, just on a scale so small that we need very precise instruments to notice it. Another piece of evidence comes from muon particles in the atmosphere. Muons are subatomic particles created when cosmic rays from space collide with molecules high in the atmosphere. These particles exist for a very short time. Based only on their lifetime when at rest, many muons should decay before they can reach near the ground. But in reality, scientists detect many muons at ground level. How do they travel so far? Because they move at very high speeds, close to the speed of light. As observed from Earth, their time is stretched. It is as if they have extra time to pass through the atmosphere before decaying. This is not magic. This is relativity happening right above our heads, inside tiny showers of particles arriving from the universe. The muon example is very important because it shows that time dilation is not only an idea for imaginary ships, it affects real particles measured in the real world. A muon has mass, so it cannot reach the speed of light. It still has a lifetime. It still decays. It still belongs to the world of things that have proper time, but because it moves so fast, its time compared with ours is stretched. It stands, in a sense, near the edge of light, where matter begins to show us that time is not rigid at all. From a tiny particle we cannot see with the naked eye, we learn something immense. Time is not only a feeling inside the mind, it is part of the physical structure of the universe. When we understand this, we also understand why the question about photons must be stated very precisely. A ship near the speed of light still has people inside it. Those people have bodies, clocks, memories, and the feeling of waiting. A muon near the speed of light still has mass, still has a lifetime and still decays. But a photon is different. A photon is not an object with mass trying to run very fast. It always travels at the speed of light in a vacuum. It has no resting frame like a human being does. So we cannot say that a photon feels its journey as long or short. We can only say that according to our clocks, light from a distant star may take a very long time to reach us. Turning the photon into a traveller with emotions and age is a poetic image, but it is not the precise language of science. That difference is exactly what makes the story deep. Light does not age the way we do, not because it has a magical power against time. It does not age the way we do because it is not a living body. It has no cells to wear down, no skin to wrinkle, no heart to count beats, and no memory with which to feel the past drifting farther away. It does not carry an internal clock like a human being does. We age because we are living matter. Our bodies change, repair themselves, grow tired, recover, and gather memories. We live in time not only through clocks, but through the whole body and mind. So when a photon from a distant star touches our eyes, ageless light meets a living being with age. And that moment is where physics comes very close to life. Imagine you are looking at a star at night. Its light may have left that star many years ago. When it began its journey, you may have been in a very different moment of your life. Perhaps you had not yet met someone. Perhaps an important memory had not yet happened. Perhaps a city, a home, or a habit inside you had not yet formed. But that photon kept travelling, not knowing who you were, not knowing whose eye it would meet, not knowing how much the world below had changed. When it arrives, you see a point of light. In your eyes, the past of the star becomes the present of awareness. The photon does not remember the journey, but you may remember the moment you saw it. It has no age, but it reveals the age of the universe and the age of your own life. Perhaps this is why time in this story feels both scientific and mysterious. It is not mysterious in a vague or false way. It is mysterious because when science is seen deeply enough, reality becomes far stranger than ordinary intuition. A clock flying very fast can run more slowly than a clock that stays behind. A muon can live long enough to reach the ground because it moves close to the speed of light. An imaginary traveller can return younger than the person who waited. And a photon, which always travels at the speed of light, forces us to pause before the question, could there be a kind of existence where human biological time no longer applies? The answer does not require us to turn the photon into something mystical. We only need to understand that a photon does not live as we do, does not age as we do, and cannot be placed simply inside our story of time. This also helps us look back at our own lives more gently. If time were only an absolute river, everything would simply be swept along in the same way. But relativity shows that time is deeper than that. In physics, it depends also on motion and the frame of reference. For human beings, it also depends on the body, memory, and emotion. 1 minute in pain can feel long, 1 peaceful year can pass quickly, and 1 glance can remain in memory far longer than its actual duration. This is psychological time, not the same as physical time dilation, but both remind us that time is not only a number on a clock face. Time is the way existence is spread out. For a photon, we do not have that in a story. For a human being, every moment can become part of a life. When an object approaches the speed of light, the difference in time becomes stronger. But the word approaches is very important. An object with mass can get close, but it cannot reach the exact speed of light, because the energy required would rise toward infinity. A ship, a human being, a clock, all of them still belong to the world of mass. So even though their time can slow down compared with the outside world, they still do not become light. They still have proper time. They still age, although they may age less than someone who stayed behind. A photon is not a finish line that a ship can reach with a stronger engine. A photon belongs to a different state. It has no resting mass, it always moves at the speed of light in a vacuum, and it has no resting frame that we can describe like an ordinary observer. If we imagine a traveller returning after a near light-speed journey, the story becomes deeply emotional. The door of the ship opens, the traveller steps down carrying fewer years in their body. The person who stayed behind has lived through more seasons, more nights, and more moments of waiting. They meet again, but time between them is no longer the same. This is a powerful image because it shows that relativity is not only a dry formula. It touches age, separation, memory, and the fragility of human life. But even if that traveller is younger, they are still a being inside time. They can still tell the story of the journey, and to tell a story means there is memory before and after. A photon does not tell the story. A photon is simply emitted, travels, and is absorbed. When it touches your eye, it does not say, "I have been travelling for so long." The phrase "for so long" belongs to us. So when we say that time is not one river shared by everything, we are not denying everyday life. In the kitchen, 1 minute is still enough for water to grow warmer. In the bedroom, 1 hour is still enough for the body to sink more deeply into rest. In a human life, 1 year still leaves traces behind. But at very high speeds and in precise measurements, time reveals itself as something deeper than the clock on the wall. It is not completely separate from space. It is not exactly the same for every motion. It is not one single ticking sound imposed on the entire universe. It is more like the soft fabric of space-time, where each object moves along its own path, and that path determines the amount of time the object experiences. Here, the story returns to the central point of the entire video. We cannot truly travel alongside a photon. We cannot ask a photon what it sees or how long it feels the journey has taken. But by looking at the photon, we understand that human time is not the only way the universe exists. For us, time is heartbeat, memory, old age, sleep, and the very real changes inside the body. For a ship near the speed of light, time still exists, but it can pass more slowly compared with the person who stayed behind. For a photon, the language of time as a passenger experiencing a long journey no longer fits. And that difference makes light a strange kind of mirror. It does not age as we do, but it helps us understand why we age. Let that thought settle slowly. 1 clock remains in a quiet room. Another clock travels on a ship near the speed of light. Both are honest, but when they meet again, they may tell 2 different stories. A muon is born high in the atmosphere, rushes down toward the ground, and exists longer in our observation because it is moving extremely fast. A photon leaves a distant star, crosses a vast emptiness, and touches a human eye on a quiet night. All of these images point to the same thing. Time is not an absolute flow that is identical for everything. It depends on motion, on the nature of the object, on the way we measure, and for human beings, on the living body moving through each moment. Maybe this is what makes our existence both fragile and beautiful. We cannot travel with a photon, so we cannot escape to time the way light seems to escape biological aging. But because we are not photons, we have the ability to feel a slow evening, a distant memory, and the approach of sleep. Light does not age you the way we do, but it also does not know that it has crossed the darkness. We grow older, but we know that we have lived. We can look at a ray of light and wonder where it came from. We can hear a story about time dilation and feel that the universe becoming wider, deeper, and stranger. We may not be able to catch up with light, but we can let light lead us toward a gentler understanding of time. So when we approach light through imagination, we are not only learning about physics, we are learning about the limits of intuition. We are learning that 1 minute in everyday life may seem simple, but 1 minute in the deep universe can depend on motion. We are learning that clocks do not only measure time, they also reveal an object's path through space-time. We are learning that a photon is not an immortal traveller, but a particle of light without biological time like ours. And we are learning that not being light is not a flaw. It is the reason we have memory, waiting, age, emotion, and sleep. Light travels very fast. Human beings travel much more slowly. But within that slowness, we can understand, we can remember, and we can feel each moment as something that will never happen the same way again. By this point, the original question begins to open more clearly. If you could travel alongside a photon, how would time disappear? The answer is not that you sit on a photon and watch the clock stop, because that cannot happen according to physics. The deeper answer is this. The closer an object with mass approaches the speed of light, the more its time slows down compared with an outside observer. But a photon has no rest frame from which we can tell its experience of time as if it were human. So light does not age the way we do, not because it has an endlessly extended life, but because it does not belong to our kind of biological time, memory, and age. It is a reminder that time is not absolute, and that human life is precious precisely because we are truly moving through time. By this point, through imagination, we have come very close to the boundary of light. We have seen that the faster an object with mass moves, the more its time slows down compared with an outside observer. We have seen that a ship travelling near the speed of light still has its own clock, and the people on board still have heartbeats, memories, and the feeling of each moment passing by. But as soon as we want to take one more step and ask, so what if we could truly travel alongside a photon, we have to pause gently, because this is where the question becomes very beautiful, but also very easy to misunderstand. In physics, there is no chair placed beside a photon for us to sit on. There is no room standing still with a photon where we can look out through a window. There is no tiny clock that can be tied to a photon so we can ask how long it has been travelling. A photon always moves at the speed of light in a vacuum, and because of that it does not have a rest frame the way an object with mass does. In other words, the photon's point of view is a poetic image, not a real physical position we can step into. If a person is sitting on a train, we can say that person has their own frame of reference. If a clock is resting on a table, we can say that a clock is at rest in the room. If a speck of dust is drifting slowly through the air, we can still imagine an observing frame moving along with it. But a photon is different. In every inertial frame of reference, light in a vacuum is still measured as moving at the speed of light. If there were a frame in which a photon stood still, light in that frame would have a speed of 0, and that would contradict the foundation of special relativity. So we cannot truly say, now, let us stand still with a photon and look at the universe from there. That sentence may be beautiful for the imagination, but it is not the precise language of science. This does not take away the mystery of the question. In fact, it makes the question deeper. Because sometimes the strangest thing is not what we are able to imagine, but what the universe does not allow us to imagine in the usual way. We can imagine ourselves flying fast, flying very fast, flying close to the speed of light. We can imagine the clock inside the ship running more slowly compared with clocks on Earth. We can imagine a traveller returning younger than the person who waited behind. But when we reach the photon, familiar human intuition stops in front of a closed door. Not because we lack images, but because the very idea of being at rest with a photon is no longer valid. And that closed door opens into a more beautiful truth. Light does not age like human beings, not because it is living an immortal life, but because it does not belong to the kind of time experienced by living bodies. Picture a photon leaving a very distant galaxy. According to our clocks, that light may have travelled through space for millions or even billions of years before reaching a telescope. During that time, countless changes may have taken place on Earth. Oceans changed colour under different climate eras. Mountains rose and were worn down by rain and wind. Life moved through long branches of evolution. Creatures appeared, disappeared, left fossils behind, and became part of the stone. Human beings arrived very late in that story, lifted their eyes to the sky, and received an ancient ray of light. To us, that photon is a tiny message from the deep past, but we cannot say that the photon itself sat in the darkness for billions of years, waiting, longing, or feeling itself grow old along the way. Words such as waiting, remembering, and aging belong to living beings with inner time. A photon has no such life. Maybe we can put it this way to make it easier to feel. For observers like us, the journey of light has time. We can measure how long light takes to travel from one place to another. Light from the sun takes a little more than 8 minutes to reach Earth. Light from a nearby star may take several years. Light from a distant galaxy may take millions of years. Those numbers are real in our measuring frame. But when we ask how long the photon has experienced, we enter a region where language becomes uncertain. A photon has no rest frame where we can place a clock moving along with it the way we place a clock on a ship. Along the path of light through space-time, proper time in the usual sense used for objects with mass no longer applies the way it does for human beings, spacecraft, or muon particles. We can say that the path of light is a light-like path, also called a null path where the space-time interval has a special nature, but we must avoid turning that into a story where the photon feels no time like a tiny soul flying through space. That carefulness is very important because it keeps mystery from slipping into error. The deeper science becomes, the more gentle but clear we have to be. A photon is not a conscious being. It does not see the universe contract in front of it. It is not surprised when it travels from one star to another. It does not know that it was born, and it does not know that it is absorbed. Phrases such as "for a photon, time does not pass" should only be understood as very limited expressions, helping us feel that along the path of light, the idea of proper time is very different from the time of objects with mass. If we take the language too far, we accidentally give the photon an experience it does not have, and when we do that, we lose what is truly wondrous. The universe is already strange enough without turning light into a thinking spirit. Let us return to a more familiar example. You are sitting in a dark room, watching the light from a nightlight fall across the wall. That light travels from the bulb to the wall, then reflects into your eyes in an extremely tiny amount of time. To you, everything seems almost instant. You turn on the light and the room brightens, but in truth there is still a journey. Photons are emitted, move through the air, touch a surface, and some of them reach your eyes. If the room were large enough, the travel time would still exist, just too small for us to feel. And if we replace the room with the universe, replace the wall with a galaxy, and replace the light bulb with an ancient star, that journey becomes enormous according to our clocks. The difference is not whether the photon feels that it has taken longer. The difference lies in the observer who has a clock, and in the distance the light has to cross. That is why the photon's point of view should be treated as an imaginary bridge, not a real home. We step onto that bridge in order to look back at our own time. We do not stay there too long, because if we believe we can truly stand with a photon, we fall away from science. But when used correctly, the metaphor is powerful. It shows us that human time is tied to mass, the body, motion slower than light, and the possibility of carrying a clock along with us. We can wear a clock on our wrist because our wrist has mass and moves more slowly than light. We can grow old because our body goes through biological processes. We can remember because our brain preserves traces of change over time. A photon has none of these things. It does not lose its childhood because it has no childhood. It does not fear old age because it has no biological life that can grow old. This makes light both foreign and familiar. Foreign because it does not belong to our inner time. Familiar because it constantly touches our lives. Every morning, photons from the sun enter your eyes and reveal the shape of the world. Every evening, photons from a small lamp help make the room less dark. In a hospital, photons in the form of X-rays can pass through soft tissue and help doctors see structures inside the body. In a telescope, photons from distant galaxies help human beings build a history of the universe. Light has no memory, but it helps us create memory. Light does not age in the biological sense, but it allows us to see things that are aging. A ray of light falling on a table can reveal an old scratch in the wood, wrinkles on a hand, and tiny dust drifting slowly through the air. A photon does not carry age, but it makes age visible. Here, the story of the photon begins to become a story about the observer. Without an eye looking at it, light is still light. It still travels, it still interacts with matter. But when light touches the living mind, it becomes colour, image, and memory. A photon from a distant star may end its journey in your retina. From there, a chain of nerve signals begins, enters the brain, and then you see a point of light in the sky. That point of light may remind you of an old night, someone who is far away, a time you stood still under cold air, or simply the feeling of being very small in a very wide universe. The photon does not carry those emotions. They are born in you. Light has no age, but when it meets a human being, it enters a world of memory, fragility, and meaning. Perhaps this is where science touches a spiritual feeling in the clearest way. Not by saying that a photon has a soul, not by saying that light has consciousness, but by realizing that a mindless particle of light can connect a very distant event with a very near emotion. A photon leaves an ancient star, crosses silent space, and touches the eye of someone lying awake in the night. It knows nothing about that person, but that person can know something about the universe because of it. That person may feel time suddenly becoming wider, their own life becoming slower, their breathing becoming softer. Science is not lost in that feeling. Science is the ground that allows the feeling to stand. Because the more correctly we understand the photon, the more we see that the strange thing is not that light has a soul, but that light, without a soul, can still awaken the soul. If we try to ask, what does a photon see? The serious answer is this: it is not a proper physics question. Seeing requires an observing frame, a process of receiving information, and a structure that can distinguish before from after. A photon has no eyes, no brain, and no sensation. If we say the photon sees the universe contracted into a point, that is an image that may spark curiosity, but it should not be used as truth. In relativity, when an object with mass approaches the speed of light, lengths along the direction of motion can contract in measurement, and time can dilate. But a photon is not an object with mass gradually approaching the speed of light. It has always moved at the speed of light in a vacuum, so we cannot take formulas meant for things slower than light, simply set the speed equal to the speed of light, and tell it as the photon's experience. That limit is not a room we can enter, it is the boundary of description. A safer way to say it is this. For us, a photon can cross an enormous distance over a very long span of time, according to our clocks. But the photon itself has no rest frame, so we cannot describe its experience of time the way we describe the experience of a traveller. If we use the idea of proper time along a path of light, we find that it is not like the proper time of an object with mass, but instead of saying the photon feels everything happen instantly, we should say that the language of feeling does not fit here. That is the difference between a beautiful metaphor and a serious scientific statement. And keeping that difference clear is how we make the story both accurate and deep. Imagine an astronomical photograph. In that image, there are thousands of points of light. Some are stars in our own galaxy, some are very distant galaxies. Each point of light sends us photons from a different moment. Some photons began their journey when there was no civilization on Earth. Some began before a continent had its present shape. Some began when the history of life was still in a very different chapter. But when the photograph is taken, all of them gather on one sensor in the same night. The observer looks at the photograph and sees a quiet beauty, but in truth it is a meeting of many layers of time. To us, those photons have travelled for a very long time, but for the photons themselves, we do not tell the story as though they are travellers who grew old together on the road. They have no faces, no memories, and no age. They are simply light that was emitted, travelled, and was recorded. This may feel strange, but it is also deeply comforting, because it shows that aging is not simply a curse of time, but a sign of a kind of existence with depth. A photon does not age, but a photon also does not live a human life. It does not know the warmth of a room after a tiring day. It does not know the feeling of hearing rain fall when sleep is near. It does not know a memory growing distant while still glowing in the heart. Human beings grow old because human beings are living bodies, with metabolism, injury, recovery, and a nervous system that keeps traces. Each day that passes is not only a number on a calendar, but a thin layer in the story of the self. Light does not carry that thin layer. It has no story of its own, but it can shine on our story, making us see more clearly that we are living inside time. There is great humility in admitting that we cannot travel with a photon. Human beings often want to place themselves everywhere, on mountaintops, at the bottom of the ocean, inside the heart of a black hole, beside light itself. But some places are not places in the ordinary sense. Beside a photon is not an empty seat in the universe. It is an idea that leads us to the edge of language. And when language stops, we do not need to be disappointed. We can sit quietly before that limit and learn to respect reality. Perhaps the maturity of the mind is not turning every question into an easy image, but knowing which questions need to be held in precision and silence. A photon does not give us a point of view, but it gives us a lesson. Not everything in the universe can be told through human experience. And yet, precisely because we cannot travel with a photon, we can see the human journey more clearly. We cannot reach the speed of light, so we remain within the realm of proper time. We cannot erase age, so we know that a day is truly a day. We cannot leave the body behind, so we feel tiredness, peace, fear, and hope. And because we have memory, we can connect moments into a life. A photon does not need rest after crossing space, but we need sleep after a long day. A photon does not remember where it was born, but we can remember an old room simply because afternoon light falls on the wall the way it did long ago. In that difference, light does not make human beings small in a cold way. It makes human beings more precious, because we have something a photon does not have: experience. A photon may leave a galaxy when there are not yet human beings on Earth, then touch a telescope tonight. To us, that is deep history. But for light, we cannot say it sat there, waiting, longing, or aging along the way. This sentence is the center of this entire section. It reminds us to hold two things at once: The first is the vastness of cosmic time according to the clocks of observers. The second is the care we need when speaking about the time of the photon itself. If we hold only the first, we can easily tell a moving but inaccurate story. If we hold only the second, the story may become dry and lose its beauty. But when we hold both, we find a balanced path. Light is a messenger of the past for us, but it is not a mail carrier who grows old because the road was so long. Now place this into a very quiet scene. An astronomer sits before a screen late at night. The telescope has gathered light from a distant galaxy. On the screen appears a faint little glow, so small that without knowing better, we might overlook it. But that little glow is not ordinary. It may be light that left the galaxy when Earth was very different. The observer knows they are looking into the past. In that moment, the human heart may tremble, not because the photon has emotion, but because human beings have emotion in front of the photon, not because light has waited to be seen, but because human beings know how to wait, how to wonder, and how to find meaning in a very small signal. The universe does not need a voice in order to make us listen. From here, we can understand why the question, how would time disappear, should not be answered too simply. If we say for a photon time is zero, we need to add that a photon does not have a point of view like a human being. If we say a photon does not experience time, we need to remember that a photon does not experience anything in the mental sense. If we say light does not age, we need to understand that it does not age in the biological sense and does not have a familiar internal clock, not that it is an immortal creature. These small distinctions make the story more accurate. And when the story becomes more accurate, its mystery does not fade. It becomes clearer, like a sky after rain, where we can look deeply without adding artificial fog. Maybe we should think of the photon as a bright thread in the fabric of space-time. That thread connects the event of emission with the event of absorption. At one end, an atom, a stir region of hot gas, or an ancient galaxy emits light. At the other end, a human eye, a sensor, a leaf, a grain of dust, or a stone surface absorbs it. Between those two ends, for an observer, there is distance and travel time, but for the photon, we do not place a life stretched along that thread. We only have a path of light in the geometry of space-time. Seen this way, the story becomes less like a journey of travel and more like a deep structure of the universe. Light does not move through its life the way we move through youth, middle age and old age. It connects events without carrying an inner history. And that is exactly what makes every moment touched by light feel special. When you see sunrise, the photon does not know it is beginning your day. But you know, when you see the light on your desk, the photon does not know whether you are reading, thinking, or slowly drifting towards sleep. But you know. When you look at a star, the photon does not know it has become a question in your mind. But you know, human time is not only counting, it is knowing that you are counting. It is the ability to feel before and after. It is the depth of memory. So when light does not age as we do, it does not make our time meaningless. On the contrary, it helps us see our time as more precious. We have something a photon does not have, an inner world for time to pass through. If we listen very carefully, this section is not saying that human beings are above light. It is only saying that human beings are different from light. The photon is a fundamental part of the physical world. Without light, we would not see stars, we would not see colour, and many forms of energy that support life on Earth would not exist. But a photon has no psychological life. Human beings do. We are far slower than light, bound by mass and age, but we can understand light. We cannot sit beside a photon, but we can build theories that explain why that question is not valid. We cannot ask a photon what it sees, but we can ask ourselves why we want to know. And perhaps that second question is the gentlest doorway. We want to travel with a photon because we want to know whether it is possible to escape time. But the photon answers in silence. Escaping time in the way light does also means not having a life like a human being. So as we continue this journey, let us hold the photon metaphor in our hands like a small lamp. It helps light the path, but we do not confuse the lamp with the whole universe. We can say that light takes us to a place where familiar time almost dissolves. But we must also remember that this is not a room a person can enter, sit down in and look around. It is the limit that objects with mass cannot reach, the place where no rest frame exists for a photon, the place where the language of experience begins to no longer fit. And because of that, the deepest mystery is not what the photon saw on its long journey, but why we, slow-moving creatures inside time, are able to understand that there are paths in the universe that do not carry time the way we do. Let that thought rest for a moment. A photon has no heart to count beats, no cells to wear down, no skin to hold the marks of years, no memory to call any place home. It does not sit in the darkness between galaxies like a lonely traveller. It does not see the universe rushing past its eyes. It is simply light, emitted and absorbed, lying along a special path in space-time. And we, as we hear this story, may feel our breathing slow down. We may remember that we are lying in a room on a specific night at a moment that will never repeat. A photon does not age the way we do, but we can understand that. And that ability to understand is a very beautiful part of being human. Once we understand that we cannot truly sit still alongside a photon, the story does not end there. It only changes direction, becoming quieter and deeper. Because if time is no longer one river shared by everything, then space cannot remain a rigid, motionless stage that looks the same to every observer. We usually think of space as the emptiness outside us. A room has a certain length. A road has a certain distance, the moon is a certain distance from Earth. A star is farther away still. In ordinary life, that way of thinking works very well. We can measure a room with a ruler, measure a road by the number of miles or kilometers, and measure a trip by hours of driving. But when speed approaches the speed of light, space begins to reveal that it is not only the silent background that things move across. Space and time are actually woven together into a deeper fabric called space-time. This may sound distant, but let us begin with a very familiar feeling. When you travel down a long road, you think the distance is out there. It feels like an objective number that does not depend on you. If a road sign says there are about 62 miles left or 100 kilometers, you believe that those 62 miles or 100 kilometers are the same for everyone. At the speed of a car, that is almost true in everyday life. But in relativity, when a person moves very fast compared with landmarks that are standing still, the distance in the direction of motion can be measured as shorter than the distance measured by someone at rest with those landmarks. This phenomenon is called length contraction. It is not because the eyes are seeing incorrectly. It is not an illusion. It is not because the map was printed crooked. It is part of the way space and time are connected with motion. Imagine a spacecraft flying toward a very distant star. For someone on Earth, that star may be dozens of light years away. That means light needs dozens of years to travel from there to here. If the spacecraft moves slowly, the journey could be so long that it reaches far beyond a human lifetime. But if the spacecraft could fly extremely fast, close to the speed of light, the people on board would not only find that their time is different from the time of those who stayed behind. According to measurements in the spacecraft's own frame, the distance to the star ahead could also become shorter. To say this carefully, the universe is not being squeezed like a sheet of paper in someone's hand. Rather, the measurement of distance depends on the frame of reference. The people who stay behind measure a large distance. The people on the ship, in their very fast-moving frame, may measure the distance in the direction of travel as shorter. So when speed approaches light, it is not only the clock that changes its story, the ruler changes its story too. This is very important for the question about photons. In everyday imagination, we often think of a journey as travelling through each foot or metre, each mile or kilometre, each light year, as if moving along a very long road. But when we touch the region near light, that way of thinking is no longer enough. A ship near the speed of light is not only moving quickly across the same rigid map, the map it uses to measure the journey is not the same as the map used by those who stay behind. For someone standing on Earth, the ship may need many years to reach a distant place. For someone on the ship, their proper time may be shorter, and the distance ahead may also be shorter. Space and time change together, so that one fundamental thing remains true. The speed of light in a vacuum is measured the same by inertial observers. This is where the universe becomes stranger than any imagined story, while still remaining very precise in physics. You can imagine space-time as a fabric made not of cotton threads, but of relationships between distance, time, motion, and light. In the slow everyday life, that fabric looks flat, firm, and easy to measure. We set down a ruler and believe that length is simply length. We look at a clock and believe that time is simply time, but when motion becomes fast enough, the hidden weave begins to show itself. Time dilates. Length along the direction of motion contracts. These are not two separate, strange tricks. They are two sides of the same structure. If only time changed while space remained absolutely rigid, relativity would not hold together. If only space changed while time remained absolute, the story would not be complete either. The universe does not operate like two separate stages, one called space and one called time. It operates as a four-dimensional reality, where space and time are deeply linked. Let us use a gentler image. You hold a paper map in your hands. When it is spread flat, two cities are far apart. But if the paper is folded, the 2 points can become closer together in the space of your hands. Special relativity does not say that the spacecraft folds space in that way, but the image helps us feel one thing. Distance is not always as simple as it feels when we look at a flat map. At speeds close to light, measured distance depends on the state of motion. The person at the rest with two landmarks will measure the proper distance between them. The person flying past at a very high speed will measure the length in the direction of motion as shorter. So a cosmic journey is not only a matter of going faster to arrive sooner, it is also a matter of the very idea of how far changing according to the way you move through space-time. Now imagine a spacecraft flying past a row of lights placed evenly through space, like glowing markers connecting Earth to a distant star. The people on Earth measure the distance between the markers and find that they are separated by a certain amount, but the people on the spacecraft travelling close to the speed of light may measure the distance between those markers as shorter in the direction of motion. From the outside, an observer may say the spacecraft is contracted along its direction of travel. From inside the spacecraft, the travellers may say that the outside distance is contracted along the direction in which they are moving. These two stories may sound contradictory, but in relativity, each story belongs to a different frame of reference and must be used in the right place. There is no absolute observer standing outside the universe, declaring that their map is the only true map. There are only measurements connected to the moving frame of the person doing the measuring. If this feels difficult to grasp, that is completely natural. The human brain was born to live at slow speeds, across small distances, within the days and nights of Earth. We did not evolve to directly feel length contraction at speeds near light. We did not need to know that a fast-moving ruler is measured as shorter in order to pick fruit, make fire, build a home, or find the way back. So our intuition is very good in the slow world, but it becomes clumsy in the world near light. Modern physics is like a soft lamp, shining into the part of reality that the senses cannot see on their own. It does not destroy everyday life. It only says that everyday life is a very small, very slow, very gentle case of a much larger structure. This also helps us understand more clearly why travelling with a photon is not like an ordinary flight. A person on a train can watch each mile marker pass outside the window. A pilot can calculate the remaining distance. A slow spacecraft can be tracked with an orbital map. But a photon is not a passenger moving past each spatial marker in its own proper time. For objects with mass, as speed gets closer to light, the distance ahead can contract in that object's frame, and time compared with the outside world can slow down. But a photon has no rest frame from which we can say it sees distance contracting in any particular way. We can only use the photon as a limit, a doorway for reflection. The closer we come to that doorway, the more the everyday map stops working. Each foot or meter, each mile or kilometre, each second, each light year, no longer remains as simple as when we walk down a dark road. Let us return to the night sky. Human beings look up and see distance. A star is far away. A galaxy is even farther. A faint patch of light may lie deep in the universe's past. We use light years to describe that distance, but the light year itself carries the flavour of time inside it. It is the distance light travels in 1 year. So whenever we speak about vast space, we have quietly brought time into the story. Space and time are no longer separate in our feeling. A distant place is also an old place in our view. A distant galaxy is not only out there, it appears to us as it was when its light left. When we understand this, the sky is not only wide, it is deep. It has the depth of space and the depth of time at the same time. Light crosses that distance without carrying old age the way human beings do. This is the point we need to hold firmly. For us, light from a distant galaxy takes millions of years to reach a telescope. During that time, according to clocks on Earth, mountains may rise, seas may retreat, life may change form, and human beings may appear and lift their heads toward the sky. But we do not say the photon has lived through those millions of years the way a living being passes through youth and old age. We also do not say the photon sees the universe compressed in front of it like a person inside a cabin. We only say that for objects with mass approaching the speed of light, time and distance are measured in unusual ways, and with the photon, we have reached the limit where no rest frame exists. That difference is the scientific soul of the story. There is a classic example in relativity often told through the image of a long object entering a shorter space. If a very long rod moves quickly through a barn, the person standing in the barn may measure the rod as shorter along the direction of motion, but the person moving with the rod sees the rod as having its normal length in their own frame, while the barn is the thing moving and contracted. This story can become confusing if told too quickly, but it teaches an important lesson. Length is no longer an absolute number separated from the person who measures it. To say how long an object is, we have to say which frame it is measured in. In the same way, to say how long a journey takes, we have to say which clock is doing the measuring. When speed becomes large enough, both space and time require us to be clear about who the observer is. This may sound dry, but if we listen for a moment, it has a quiet beauty. There is no rigid stage for every fate. There is no invisible ruler imposed on every journey. There is no single clock forcing everything to age in the same way. Each thing, depending on its mass, motion, and path through space-time, has its own way of being measured. We human beings move very slowly, so these differences almost disappear in everyday life. Because of that, we can live in a stable world. The table does not contract before our eyes. The room does not change length because we walk through it. A minute is still enough for us to let our breathing slow down, but at the deeper level of reality, everything is more delicate. The universe is not rigid like a room. It is soft like a fabric measured differently by observers moving in different ways. If one day we could send a spacecraft very close to the speed of light toward a very distant star, the people who stayed behind might wait for a long time. They would look at their clocks and see many years pass, but the people on the ship might experience less time. Not only that, in their way of measuring, the distance to the destination could also be shorter. This is the strange cooperation between time dilation and length contraction. The spacecraft does not break the law of light. It still does not exceed the speed of light. But because space and time are measured differently in different moving frames, its journey does not match everyday intuition. We do not need to turn this story into magic. It is already wondrous enough by itself. The closer we come to light, the more the map and the clock change together. But let us keep the carefulness we learned in the previous section. A ship near light is still not a photon. It still has its own rest frame. The people on the ship still have a clock beside them. They can still say, "Oh, I travelled for this many years according to my own proper time." They can still measure distance within their own frame, but a photon has no rest frame. So we cannot say how a photon measures distance, how it sees space contract, or how it feels time disappear. All of those sentences use the language of an observer with a body and a clock. For a photon, that language no longer fits. We can approach it through mathematics and the geometry of space-time, but we cannot turn the photon into a character sitting in a cockpit. This is exactly why the story of what if you could travel with a photon is both fascinating and dangerous. It is fascinating because it opens a beautiful image. Time slowing down, distance contracting, the universe seeming to press toward an unimaginable limit. But it becomes dangerous if we forget that you cannot truly travel with a photon. An object with a mass cannot reach the speed of light, and a photon does not have a human point of view. So the best way to use this question is to treat it as a window, not a chair. We do not sit in it and tell an incorrect story. We look through it and see that time and space are not rigid absolutes. They are connected parts of a deeper reality. When people hear the word space-time, many may think of grand images. Black holes, galaxies, curved universes, grids bending downward. Those images belong to many other parts of relativity, especially when we talk about gravity. But even in special relativity, without black holes or strong gravitational fields, we already see that space and time are not separate. All we need is motion that is very fast, close enough to light, and clocks and rulers begin to reveal that connection. A person at rest does not have the right to say that their time and distance are the final absolute truth. A moving person does not have the right to deny the other one either. Each person measures from their own frame, and the measurements are related through the structure of space-time. Perhaps this makes reality feel like a dream written with very strict laws. It is not vague because there are equations, experiments, and precise predictions, but it is also not as rigid as old intuition. It has a softness, a strangeness, an almost meditative quality. Time can dilate. Length can contract. What is far can be measured differently when you move fast enough. What is long in time may not be the same for the traveller and the one who stays behind. And at the boundary of all these things, the photon appears quietly as a reminder. There are paths in the universe that cannot be understood by imagining yourself sitting in a vehicle and looking out a window. There are limits that require the mind to become humble. Place yourself in a very quiet night. You look at starlight. You know that light comes from far away. Before, you may have thought only this: that place is very distant. Now, you may feel another layer. Distance also means that light needs time to reach us, and that time is measured in our frame. If a spacecraft travelled close to light toward that place, the time of the people on board and the distance they measured might not match the way we measure from here. If we speak of the photon from that starlight, we have to leave behind the image of a traveller altogether. Space and time in the story of light are no longer a road and a clock in the human sense. From one small point of light, a vast structure of physics opens, yet it remains very quiet, like a door opening in the dark without making a sound. You may wonder, if space contracts in the direction of motion, does that mean an object is really crushed? The answer is no, not in the everyday sense. Length contraction is a measurable effect between frames of reference in relative motion. A person moving with the object does not see their own object compressed in their own frame. The spacecraft does not feel its body being squeezed just because it is moving uniformly in its own frame. The person outside may measure the spacecraft as shorter in the direction of motion. The person on the spacecraft measures the spacecraft as normal, but measures outside distances differently. This is not a visual illusion, and it is not a mechanical force crushing the object. It is the difference in measurements of space and time between moving frames. Saying it correctly keeps the story clear and helps us avoid misunderstanding. The deeper we go, the more we see that light acts like a central pillar in all measurements. If observers moving in different ways all measure light in a vacuum as having the same speed, then time and space must adjust in their measurements. This goes strongly against intuition. In everyday life, if you run toward a ball flying toward you, you see the ball approach faster. If you run in the same direction as the ball, you see it approach more slowly. But light does not behave like a ball in old intuition. No matter how the light source and the observer move within the scope of special relativity, the speed of light in a vacuum is still measured as the same value. For that to be true, the universe does not preserve absolute time and absolute space in the old way. It allows them to relate flexibly to one another. This is why when we say time disappears, we must understand that it is not a scene where a clock cracks open and falls into an abyss. For human beings, when moving fast, proper time does not disappear. It only differs when compared with another observer. For a photon, we do not speak of an experience of time the way we do for a human being, and when familiar time dissolves at the limit of light, familiar space dissolves with it. There is no longer a rigid stage where the photon simply moves through each foot or meter, in each second like a person walking down a road. There is no everyday map that is enough to describe the whole thing. Instead, there is space-time, where the path of light has a special nature, where the proper time of objects with mass cannot be applied to photons in the familiar way, and where the observer must remain humble before the limits of language itself. This does not make life more distant. On the contrary, it can make life feel closer. When you look at light on the wall, you are seeing something very ordinary, but behind that ordinary thing is an order so deep that it changes the very concepts of space and time. When you look at a road, you see distance. When you wait for someone, you feel time. When you remember a memory, you touch the past. But in the deeper foundation of the universe, these things are more closely connected than we once thought. Distance can become light travel time. Time can change with motion. Length can depend on the measuring frame. And light, the thing that quietly shines on everything, stands at the limit where the human map no longer remains whole. If we return to the central takeaway, everything begins to become very clear. You cannot travel with a photon, you cannot see the world from the photon's place. But when you imagine that boundary carefully, you understand why light does not age the way human beings do. It has no body to pass through biological time. It has no rest frame in which it can carry a clock the way we do. It does not belong to an ordinary journey through space where each second and each foot or meter is experienced as in human life. And because of that, time and space in the story of the photon cannot be told with simple images. A photon is not an immortal traveller. It is the limit that helps us understand that human time and human space are only one very particular way existence appears. Let that sentence sink in slowly. Time and space are not two rigid boxes trapping the universe inside. They are more like a soft fabric, measured differently depending on how you move. For those who move slowly, the fabric seems almost flat and still. For those approaching light, the fabric begins to reveal strange threads. Clocks slow down, lengths contract, distance and time are no longer independent. And with light, we touch the edge of the fabric where familiar words such as experience, see, wait, and grow old no longer work the way they do when we speak about human beings. That is not a failure of intelligence, it is a lesson in humility before reality. Human beings look up at the sky and see distance. Light crosses that distance without carrying old age, and right here, space is no longer a rigid stage, time is no longer a shared ticking sound, and both become a soft fabric of the universe. We stand inside that fabric with bodies that have mass, with hearts that count beats, with memories that know the difference between yesterday and today. We cannot become photons, but we can let photons lead us toward a gentler understanding. Every second of ours has value because we are truly living inside it. Every distance we see has depth because light needs time to arrive. And every time we ask about light, we're also asking about the way we ourselves exist in space-time. And after moving through the speed of light, time dilation, length contraction, and then reaching the boundary where we cannot truly stand still alongside a photon, the story begins to return to a place very close to us, the body that is listening in the night. Because the question about the photon is ultimately not only a question about light, it is also a question about human beings. Why can light travel through the universe without aging the way we do? Why does a photon carry no age while we do? And why is the fact that we cannot become light not a failure, but perhaps one of life's quiet gifts? Light may not age in the biological sense, but it also does not know that it has passed through darkness. Human beings are different. We grow older, but we know that we have lived. We grow tired, but we can rest. We pass through time, but time itself gives depth to the soul. A photon has no heart to count beats, no cells to repair, no memory with which to call a moment long ago, no childhood, no first afternoon, no long night of restlessness before slowly drifting into sleep. It is simply light, a quantum of the electromagnetic field emitted, transmitted, and then absorbed. But human beings are living matter, and living matter does not merely exist, it experiences. Imagine placing a hand on your chest. Each heartbeat is a small marker. It does not only pump blood, it says that the body is still moving through time. From the time you were very small until now, your heart has beaten countless times. Cells in your body have been born, worked, repaired, replaced, or slowly lost some of the ability they once had. Throughout each day of life, the body has to process energy, deal with small injuries in genetic material, repair errors, remove damaged cells, and keep its inner balance. Aging is not just a number on paper, it is the trace of millions of quiet biological processes. A wound needs time to heal, a muscle needs time to recover, a memory needs time to form, a human life needs time to become itself. A photon has none of those processes. It does not metabolize energy in order to keep living. It has no tissue, no blood, no immune system, no nerve cells. So when we say a photon does not age, we should not imagine it as an immortal creature, forever young in the darkness. It has no youth, because it has no childhood. It has no immortality, because it has no life in the biological sense. We age because we live inside a body that must maintain itself from moment to moment. That body is beautiful precisely because it is fragile. It has to repair, rest, sleep, wake up, and adapt. Each passing day does not live only on a calendar. It moves through the skin, The eyes, the bones, the brain, the voice, and the way we see the world. There is something very deep here. Human consciousness is built on continuity. You know that you are you because there is a stream of memory connecting yesterday to today. You remember an old room, a voice, a rainy season, a hand, a morning that once made you feel peaceful. Those memories do not stand alone like stones scattered on the ground. The brain connects them into a story. That story says there was a person who went through those things, and that person is still here. Without time, that story would dissolve. Without before and after, there would be no childhood, no growing up, no loss, no healing, no hope. Our consciousness needs time the way music needs rhythm. If every note happened at once, the music would no longer be music. That is why the question about the photon does not only carry us outward into the universe, it also carries us inward into ourselves. A photon has no stream of memory. It has no self that can say, I was there, and then I came here. But human beings do. We do not receive light only with our eyes. We receive light with our whole inner life. A ray of late afternoon sunlight falling across the floor can make someone remember an old home. A warm yellow lamp can make someone feel safe. A faint star in the sky can suddenly make someone feel very small, but also very awake. A photon does not carry those emotions inside it. Emotion is born when light touches a mind with its own history. Light has no memory, but it can awaken memory. Imagine a photon leaving a distant star long ago. During that journey, according to our clocks, Earth has changed. Mountains may have worn down a little. Seas may have risen and retreated through long eras. Trees may have grown, died, and become soil. Many generations of living beings may have lived in the dawn and then disappeared into the night of history. And then, one evening, that photon touches the eye of a human being looking upward. For the photon, we do not tell a story of waiting. But for the person looking, that moment can become a memory. This is a strange meeting. Something without age touches a being with age. A signal without emotion stirs a mind full of emotion. A particle of light that does not know the past opens a feeling of the past inside a human heart. So human aging is not only loss, it is also accumulation. A face changes because of time, but within that change are the years that have been lived. A hand may have more lines, but it has also held, worked, touched loved ones, opened doors, and held on to something important. A voice may become slower with age, but inside that voice there is experience. A photon has no wrinkles, but it also has no hand that has ever held anyone. A photon does not grow tired, but it also does not know the feeling of rest. A photon loses nothing, but it also has nothing to remember. We are touched by time, and yet we can turn time into meaning. When the body ages, not everything happens in a single day. It is a very long and complex process. Inside the body, cells constantly face damage from metabolism, from the environment, from errors in copying genetic material, and from chemical reactions within life itself. The body has many repair systems, but no system remains perfect forever. Over time, some damage accumulates. Some cells enter states where they no longer divide the way they once did. Some tissues recover more slowly. The body gradually changes. This is not a simple failure. It is the cost of existing as a complex living system inside time. Life does not stand still, and because it does not stand still, it has history. The brain is the same. It is not a hard box that stores memories exactly like objects placed in a drawer. The brain changes with experience. Neural connections strengthen or weaken. Things that receive attention may be stored more deeply. Things that repeat may become habits. Sleep helps the brain reorganize part of what it has gone through, strengthen some memories, soften some tension, and prepare for a new day. Each night when you sleep, consciousness does not simply turn off like a lamp. The body enters delicate rhythms of rest. The brain still works in other ways. Memories may be processed, emotions may be regulated, energy may be restored. So sleep is not an empty gap without meaning. It is part of how life continues moving through time without breaking apart. In the light of this story, sleep becomes very beautiful. A photon does not need sleep. It does not need to close its eyes, does not need to dream, and does not need to recover after a long journey. But human beings, we, after a day of sound, light, thought, worry, and desire, the body needs to return to a softer darkness. Every evening of going to sleep is one more time consciousness gently loosens its hold on the outside world. We do not disappear completely. We move back into another rhythm. The breath slows. The muscles soften. The images of the day may slowly dissolve into dreams. If the photon is an image of what carries no old age, then sleep is an image of what is deeply human. We need rest because we have bodies. We need dreams because we have minds. We need night because we are not light. Perhaps that is why when human beings speak about time, we do not speak only with clocks. We speak with feeling. 1 hour of waiting can feel longer than a peaceful afternoon. A memory that lasted only a few seconds can remain in the heart for many years. A sleepless night can make the body feel as if it has travelled a very long distance. But that is psychological time, different from physical time dilation. Even though they are different, both point toward one truth. Time is not simple. In physics, it depends on motion and frame of reference. In life, it is felt through the body, emotions, and memory. A photon has neither kind of experience. It has no biological clock, and no mind with which to feel that something is long or brief. That is exactly why light becomes a mirror in which we can see the depth of human time. Think of a very quiet evening. You turn down the lights in the room. Only a thin streak of light remains on the wall. Within that streak are photons constantly arriving and being absorbed. They do not know this room is a place of rest. They do not know you are tired. They do not know that a day has just passed through your body. But you know your shoulders have been tense, your eyes have grown weary, and your mind has passed through many small things. You know night is arriving like permission to let go. And when light touches your eyes, it does not only create an image, it also makes clear the difference between you and the photon. Light travels without needing rest. You rest because you are alive. This does not make human beings weaker. On the contrary, it makes human beings deeper. We cannot reach the speed of light. We cannot step outside time like a photon. We cannot leave behind mass, cells, tiredness, and age. But these very things give us an inner life. Without time, we would have no growth. Without change, we would have no story. Without loss, we would not understand what it means to protect what matters. Without tiredness, we would not know the gentleness of rest. A photon does not age, but it also has no evening in which to be comforted. Human beings age, but we can lie down, breathe slowly, and feel that we are still here. There is an almost spiritual feeling in this, but it does not need to leave science behind. Spirituality here does not mean giving consciousness to the photon. It does not mean saying that light has a soul. It does not mean turning physics into magic. Spirituality here is the silence that comes when we realize the universe is larger than our intuition, and life is more fragile, but also more beautiful than we imagined. A particle of light can cross enormous emptiness without aging the way we do. A human body cannot, but that body can love, remember, grieve, hope, sleep, dream, and understand part of that particle of light. If the photon is a cold line through space-time, then the human being is the place where that line becomes emotion. When we look back at the whole journey, we see that the question, how does time disappear? Here it is no longer a wish to escape human life, it becomes a way to understand human life more clearly. If you could travel alongside a photon, in the precise physical sense, you could not, because a photon has no rest frame and you have mass. But if you travel with a photon through careful imagination, you may see that your own time is more precious. You may understand that we age not because we are lesser than light, but because we are a different kind of existence. We live through process. We are made of continuing changes. We have a self because memory keeps connecting moments together. We are not photons, so we can say yesterday has passed, tonight is here, and tomorrow is still a promise. A photon has no childhood. It has no first time seeing the ocean. No first time hearing a song that softens the heart. No person to remember. No room that makes it feel safe. No regret. No hope. It does not lose anything in the human sense. But it also receives nothing in the human sense. We move far more slowly than light, and yet we can move through a life full of layers of meaning. A streak of sunlight on the wall can connect the present with the past. A star can connect the human being with the universe. Sleep can connect tiredness with recovery. In that very slowness, time is not only the thing that takes away, it is also the thing that allows everything to have depth. Maybe one day when you see light falling through a window, you will see it a little differently. There is no need to think too much, just remember that that photon does not age the way you do. It does not carry an inner story, but when it touches your eyes, it enters your story. It makes the room appear, it brings colour back, It may awaken a memory that seemed to have been sleeping, and in that moment, ageless light meets aging consciousness. The outer universe meets inner life. A very small physical event becomes a deeply human experience. We can also look at aging with a softer heart. Aging is not only losing speed, losing youth, losing days that have already passed. Aging is also gaining deeper layers. A person who has lived longer does not only have more years, they have more traces of time in the way they see, the way they remain silent, the way they forgive, the way they understand that an ordinary day is also precious. The body may slow down, but the mind may become softer. Things that once seemed very important may give way to peace. Large worries may become smaller under the light of time. A photon does not have that kind of growth. It does not learn from its journey. But a human being, if fortunate, can learn how to slow down without feeling meaningless. And perhaps this is the strangest thing of all. When we look at a photon, we are not only looking at light. We are looking at a limit human beings cannot cross. We are looking at a reality where time can stretch and bend so far that it almost disappears from familiar intuition. But at the same time, we are also seeing the beauty of still being here, in a slow body beneath a silent sky, hearing each second pass like a very small whisper from the universe. We are not light, so we cannot cross the universe without aging. But we are not light, so we can lie beneath that light and feel life. Let this image remain. A photon crosses darkness without knowing darkness. A human being moves through time and knows they are moving through it. A photon has no memory, but it can make memory flare awake. A human being has memory, so sometimes one small ray of light is enough to open an entire region of the past. A photon does not need sleep, but human beings need sleep in order to keep living, keep remembering, and keep softening after long days. And precisely because we need sleep, rest, and recovery, we understand time with the whole body, not only with numbers. If in the earlier parts light taught us about speed, limits, time dilation, and length contraction, then here light teaches us about the difference between existence and experience. A photon exists as light. A human being experiences as life. One does not carry biological age. The other is made of biological time. One has no inner life. The other turns the world into memory, meaning, and dreams. So light does not make human beings small in a cold sense. It makes us small in a more sacred way. Small but aware of our smallness. Fragile but able to love that fragility. Finiment but able to look at something almost ageless and understand a part of it. At the end of this journey, we can say very gently, light may not age, but it also does not know that it has passed through darkness. Human beings are different. We grow older, but we know that we have lived. We grow tired, but we can rest. We pass through time, but the time itself gives depth to the soul. And if tonight you feel your mind slowing down, that too is a beautiful part of being human. You do not need to chase the photon. You do not need to escape time. You only need to lie still, breathe slowly, and let the light of this question settle softly inside you. Because sometimes, understanding that we are not light is exactly how we learn to love each moment we are given inside time. So we have travelled together through a very quiet journey, from a tiny photon to the speed of light to the dilation of time, and then into deeper questions about space, consciousness, and human aging. We have seen that light is not only what helps us see a room, the sky, or a distant star. Light is also a doorway into the strange nature of reality, where time is no longer as simple as the ticking of a clock. We cannot truly sit beside a photon. We cannot ask what it sees, what it remembers, or how long it has been travelling. A photon does not have a resting point of view the way a human being does, and objects with mass, like us, cannot reach the speed of light. But that very limit helps us understand something precious. Time is not a river that flows the same way for everything. For human beings, time is heartbeat, breath, memory, age, tired days, and nights of rest. For light, the journey across the universe is not a long lifetime the way we might imagine. If tonight you see a small ray of light, remember that it may have travelled a very long path to reach your eyes. It does not age the way we do, but you can feel it. You can think about it. You can let it remind you that every second of human life, fragile as it is, still has its own depth. Because we are not light, we know how to wait, how to remember, how to grow tired, how to sleep, how to wake up, and how to cherish a peaceful moment. Thank you for staying with Drift into quiet knowing on this gentle journey. Now, let your mind slow down. Let your body relax as if every thought is softly dissolving into the darkness. Sleep well, sleep deeply, deeply, and I will see you again in the next journeys, where science, stillness, and the mysteries of the universe open together once more in the night.